Hi everyone, welcome back to my project box. Today I want to do a DIY build video. Something a little bit different from the normal smart home stuff. All these companies have been sending me really cool stuff. And I love making videos about them, but I want to go back to my roots where we just make stuff. So this is kind of a DIY build of a solder pot or a wire tinning pot. And it's kind of a cool old school alternative to using wire ferrules and crimping them onto your wires. And I do prefer it to certain things. I think in some ways it's a little bit better than ferrules. I know everybody's gone ferrule crazy these days, and I use them myself. I've used them in control panels before. But I want to show you how I made a really simple one. And basically all it is, I'm going to take an old school halogen bulb, like one out of this light fixture here, and I'm going to use it as a heating element, and I'm going to use a plumbing fitting like a pipe stop end, or something like this that can act as a little pot, and it's going to effectively sit on top of the halogen bulb like that. Now this lamp, you can't use it anymore because it's not LED, and nobody wants to use halogen bulbs anymore. They use way too much electricity. So I'm going to reuse the ceramic bulb. I'm going to reuse the ceramic bulb holder because obviously it can handle high temperatures because it's made out of ceramic. And then I'm going to basically have a 40 watt halogen bulb. I think these are called G9 if I'm correct. And it's going to just be held underneath here. Is we're going to just have it sitting like that, and I'm going to have a little bracket clipped over the top that screws down. And then I'm going to use some sort of metal can to house it all in, so the pot sits at the top. I've made several of these to try. Here's one I made earlier. And it works well, but it only simply has a high-low setting on it. I want to make one that's a bit more advanced where I can control the temperature a bit finer. This works well. I put it on the low setting when I'm not using it so that it stays molten. And if I need a bit more power, I put it on the high setting. So this is made from a sardine can. So we're going to do something similar to this. And it works rather well. So what we're going to do is we're going to have our halogen bulb. And I'm going to use a standard light dimmer. Now it can be the old school one that doesn't work with LED bulbs because we're dimming a halogen bulb. So the old style ones that don't work with LED bulbs, you can get them secondhand, or even if you buy them new, they're very cheap because they literally don't work with LED bulbs. I think this is an LED one, but we can use a non-LED capable one. It's basically a Variac dimmer circuit. We can build it ourselves, but these are so freely available. It's a bit silly to try and make it yourself, even though the circuit is incredibly simple. We're just going to use one out of an old dimmer switch that's kind of been recycled. So we're going to put that all inside a some sort of sardine can or a tuna can or something like that. And then the other thing we're going to do, we're going to use some of this insulation material to pack around this to keep the heat in, and also to protect the electronics so that the heat doesn't make its way through to the electronics. Yeah, and then we can demonstrate, and I'll see you how well it works.
I just happen to have a hole saw that's nearly the same size as our plumbing fitting we're going to mount inside the can, so we'll just quickly drill a hole for that. I used a lump of wood underneath to hold the can stable and make it easy for me to drill into. The hole was just a fraction too small for it to slide right through, but that's probably a good thing because then it kind of taps its own thread and makes for a really tight fit. So we can just kind of force screw it in and it sort of just cuts its own threads, and we can sort of mount it that way. Kind of handy. We have a nut and the compression ring that we can screw on the top to secure it that way as well, but I don't think it's really necessary, but we might see if we can add it later. To secure our halogen bulb onto the plumbing fitting, we just take a bit of the lid of the can We just sort of bend it over the bulb to get the general shape. And then we can just sort of bend it and cut a bit of the sides and sort of nut and bolt it down. And it makes a nice little bracket to hold it all in place. Because it's a bit springy, it provides enough tension to hold the bulb in place, and also some room for expansion when it warms up. The ceramic socket base makes a convenient way for us to connect onto our bulb / heating element, and that way we can terminate wires onto the ceramic socket.
So it's just a halogen bulb sitting on top of this with this little retainer plate.
Now it's just a matter of wiring in the power cord and the dimmer module. The dimmer module just simply goes in line with the live straight to the bulb, and the neutral connects straight to one of the bulb's terminals. We use some heatproof sleeving, of course, to just protect the connections. I added a cable GAN to provide strain relief and to stop the power cord from to be pulled out.
And now I'm just going to put a bit of this roof insulation around this to keep the heat away from the electronics, and also to stop the heat working its way back to the mounting plate. The great thing about DIY builds is that you've made it yourself, so you know how it works. This thing is made out of off-the-shelf parts, things I had lying around the house, but you can easily replace any of the components inside from your local hardware store. Everything is readily available, so it's nice to make something that you know you can repair if you need to. So it'll effectively last forever. And now I've got this base plate made out of cement. It's actually a bit of tile grout I had left over that I mixed with some sand while I was grouting, and it was just the Tupperware container, the plastic container that the grout was in, and it just happens to be the right size, and it's solid and also quite heat proof. So we'll screw that on now. So to make it a little bit easier to put the thing together, I've glued in some nuts. I've countersunk them first and then glued them into the cement base. That just makes it a bit easier to put the screws in and to screw everything together. I've also added some soft rubber feet on the bottom so that it can sort of comfortably sit on a level surface without scratching the surface. Because our brass plumbing fitting is actually a pipe stop end, it comes with a compression ring and nut. So I thought I might as well add this, since it adds a bit of extra depth to the pot. It's a little bit more thermal mass, so it might struggle to heat up a bit more, but it's nice to have the extra depth. It might actually hold the heat for a bit longer as well. Our dimmer also acts as an on-off switch and power control. So here's the finished product. As you can see, the base is made out of some cement mixed with sand. Now in reality, this is actually cement-based tile grout that I had left over when I was grouting in the kitchen, and the leftover grout I just mixed with some sand, and it was left in the little plastic container that I would mixed it in, and it makes for the perfect little base when I popped it out afterwards. And this, I believe, is a can of mackerel fish or something like that, so it's basically the same as this one. But the reason I chose this can is because I wanted a bit of separation between the dimmer module here with the electronics and the heat generated here, so that this could stay a bit cooler. And then obviously it has a bit of weight to it, so it won't move around and spill all the molten solder out.
But many things would work, something like an old floor tile or a wall tile.
Now I've drilled a little hole there so we can see the light, so it's like a visual indicator. So if we turn it on, we can see there's light coming through there. We can see the power as well.
So I cranked the power level up to 11, and what felt like an eternity was only really a couple of minutes, and then we were starting to melt solder, so really not that long. I'm just terribly impatient.
It's already starting to melt the solder. So I think Won't be long now before we can start loading it up. I'm going to use some plumbing solder and some cheaper solder that I'm not very fond of, some old solder I've got. And some lead-free solder, some bits of plumbing solder.
It's a good way to reuse all the little bits of wasted solder and the little balls that fall off your soldering iron when you clean it. Everything that ends up on the floor, just sweep it up and remelt it and reuse it.
I have some old leaded plumbing solder and some lead-free plumbing solder. So this melts at a slightly higher temperature. So this stuff you can't really use anymore for plumbing, so I'm going to just melt some of that in there.
You really do waste a lot less solder this way because you're recycling absolutely everything.
Let's give it a test. Strips a bit of wire down. Now we only need the tiniest amount of flux, just a little bit will do. And we just dip the wire in.
And just like that, we've taken our fine stranded wire and turned them into solid cores, which are perfect to go into terminal screws. And because we've used lead-free wire in our solder pot, it's a lot harder than soft lead, and the wires don't deform easily in the terminal screws.
Let's try some of this 2-core wire, speaker wire, see if we can do it all in one go.
You don't even have to twist all the strands together, you can just dip them straight in. The advantage of tinning your wires in a solder pot like this is it makes it much easier to solder your wires straight onto a PCB or onto an LED strip. Since they're pre-tinned, they take solder real easy. You can clearly see how difficult it is to put 2.5mm stranded cable into this tiny terminal screw hole, and you get the careless whiskers pushing out sideways and possibly causing a short. But with the wires twisted and tinned, they go into the terminal screw quite easily, and it's a nice tight fit. And as a bonus, once it's screwed down, you could bend the wire basically 90 degrees, and a bootlace ferrule with this little insulator won't give you that extra space. So for tight spaces, it's much better to tin the wires and then crop them short, and you can have the insulation right up to the terminal screw, and then you can bend it over and it wouldn't matter.
I don't think that the wire ferrules give you quite the same result as tinning the wires. If I bend them over, they expose some of the copper like this, and it can even break some of the conductors. I think it's just not as good as soldering. But I know you guys probably would disagree with me. Now, there's nothing particularly wrong with using ferrules. They can work really well and give you quite a neat appearance. And I think for wiring up control panels, they are brilliant. But I think if you're doing lots of wires at the same time, preparing them for screw terminals, and especially if you cut them to length and you pre-strip them and you want to do them all at the same time, you want to do it at scale. A solder pot is a device you can use to tin your wires rapidly. You can tin multiple wires at once, and you can do them very quickly, and the end result is very, very neat. And I think it's a lot quicker than bootlace ferrules or wire ferrules, crimping them and preparing them. It's just a lot faster. And I think the end result is neat too. Now, I know many of you prefer to use wire ferrules. They have their place, and I think they're great for wiring up control panels, especially the bootlace type with a little insulator at the bottom. But I don't think they're a quick fix for everything. And I'm a bit old-fashioned. I honestly believe that tinning stranded wire gives you a much better result than using these wire ferrules. Sometimes the sharp edge at the edge of the wire ferrule can cause problems and can cause the wire to break off. I know most of you will probably disagree with me and say the wire ferrules are great and they're awesome and all that sort of things. But I'm telling you, I prefer good old-fashioned tinning a wire. It means you can crop it really short. It means you can crop them very short and put them very near the screw terminal. And if you do a tight bend, it takes up very little space. Let's try to tin this rather thick wire, which can suck a lot of heat out. Let's see, with my soldering iron I would struggle with this thick wire. So let's try and make a nice loop so we can put a screw through it.
If you don't have a suitable ring terminal handy, you can always make your own in a pinch. It does the job nicely. But I think I still prefer traditional ring terminals. This little solder pot is surprisingly powerful. It really makes light work of almost anything I throw at it, even this thick twisted together wires. Prepping multi-core flex for wire termination can't be easier. Instant solid core wire.
It's impossible to do it this quick with wire ferrules. You can do maybe 5 or 6 at the same time. Now you might have noticed my old school Variac that I have. This is one that I got very cheap on Facebook Marketplace. But it's a very good one. I mean, it's very old. It's probably from the 70s or even older, maybe from the 60s. But it works really well. So if you want me to feature this in a future video, I can. So this Variac is basically a variable transformer. It's a special type of transformer. It's something called an auto transformer, but it's a variable auto transformer, a bit like a potentiometer, but a transformer version of a potentiometer. But it's not isolated from the mains. So it's not like a transformer that has a primary and secondary winding. It's one continuous winding, and the primary and secondary is kind of connected together and divided in half with a set of brushes that sort of go across the whole winding. Because I'm thinking about adding a isolation transformer to this so that we can have an isolated mains voltage supply, which is we can regulate the output voltage, and that way if you stick your fingers in the device, you have no path to earth to get an electric shock. Obviously you can still get shocked between live and neutral, but you won't get shocked if you touch just the live. The other advantage, of course, is if you're testing something with an oscilloscope, you won't blow up your oscilloscope because the oscilloscope is connected to ground or earth, and so if you isolated the output voltage of this, then you can probe with an oscilloscope on mains voltage without frying it. So yeah, so this, I want to do some modifications to this. So this might be a future up-and-coming video. So Variacs are very cool, very interesting, very sort of old sci-fi looking thing from the 1960s or 1950s. But this one is really well made. I love this thing, and I'm thinking my isolation transformer would make a handy little addition to this thing. So we can make a nice safe supply that we can probe with an oscilloscope without blowing up the oscilloscope. And also it'll make it safer to work on something because you won't have a path to ground to electrocute yourself when you touch the wires inside of the thing that you're testing. The other thing I'd like to do as well is to make a current limited supply for mains voltage as well, so that if you short something out, it doesn't blow up. So there's a whole bunch of stuff like that I want to add together for testing electronic equipment and mains voltage equipment. So that'll make for a cool future video. Let me know in the comments if that's something you'd like to see.